morning, my friends. This is lecture number 28 of the pre-calculus course, the dot product of two-dimensional vectors. Now, the objectives here in this lecture will be the dot product of vectors, the dot product theorem, we will see that, the angle between two vectors, and what is the meaning of perpendicular or orthogonal vectors. Vectors are very important in the application of physics and engineering. So the dot product of two non-zero vectors, the vectors are u, ab, and v, cd. To find the dot product, u dot v will be a times c, just a number here, a times the c, plus b times the d. That's the main definition. Simple example here, if we have a vector u, 6 minus 2, and vector v minus 5, 3. So this is a, b, and this is c and d. So the dot product will be 6 times minus 5 plus minus 2 times 3. That will be minus 30 minus 6 minus 36 is the answer. Example number 1, find the dot product of the vectors u and v. The first one is written as u and j, so we have to rewrite it. So the vector u is minus 5, 3 over 2, and vector v is already given 3 over 4 minus 3. We need the dot product. U dot v will be ac plus bd, as we have seen. So this is minus 5 times 3 over 4 plus 3 over 2 times minus 3. Just simplify the numbers and see the answer on the next slide. So that will be minus 15 over 4 minus 9 over 2. The LCD is 4, so it will be minus 33 over 4 is the dot product. Example number 2, find the dot product of these vectors, fractions and radicals. Minus 3 over square root of 2i plus 1 over square root of 3j. And there is a little trick here in the b, vector b. You see the j here as the beginning and I in the second term. So you have to rearrange it. That's a little trick here, please. So let's see. A is written as minus 3 over square root of 2. This is the x component, and the y component 1 over square root of 3. This one you have to write this one first, minus 7 over square root of 3, and the second one minus 3 over square root of 2. Now everything is easy now. Not that easy. Just multiply a times c plus b times d. Be careful about the square root numbers. So it will be 21 over square root of 6 minus 3 over square root of 6. This is the same denominator. So 21 minus 3, and then you have to rationalize, multiply by square root of 6 up and down, and then divide by 6. So the final answer, dot product, will be 3 square root of 6. Now here we have some properties of dot product. The first one says u dot v is equal v dot u, which means that the dot product is commutative. So these are the same number if you find u dot v or v dot u. Now c is a scalar, which is a real number. Scalar times a vector u dot v is the same as u dot v times the c, because c is a number, or u dot c times the v. If we have a sum of two vectors here, u plus v dot w, you can find u dot w plus v dot w, or find the sum here, u plus v as one vector, you can call it vector t, dot w, you can use the definition. Now number 4 is the most important, u dot u, so the dot product of the same vector, u dot u, is equal to magnitude of u squared. So this is a dot product of the same vector. Let's see on the next slide here from where we get this formula number 4. Let a vector u is AB. Let's find u dot u by the formula. So a times a plus b times b, which is a squared plus b squared. Leave it now and let's call it equation number 1. Now find the magnitude of the vector u here. The magnitude by the formula of the magnitude, it will be square root of a squared plus b squared. Let's square both sides here. So u, magnitude of u squared is equal a squared plus b squared. This is equation 2. Now let's compare equation 1 and equation 2. The right side, they are equal exactly here, a squared plus b squared, which means u dot u is equal to the magnitude of u squared. We can say that in English, the dot product of a vector and itself is equal to its magnitude squared. Very important property. Example number 3, given the vectors u, 2i plus j, vector vi plus kj. Find all values of k such that u plus v dot u minus v is equal to 7 over 2. So what do we have to do here? Find the sum first, u plus v, easily, and then find u minus v. So this is a vector, this is another vector. And then we find the dot product equals 7 over 2. Then there is a variable k inside we have to find. So if we add u plus v, just a normal here, this is u 2 and 1, v 1 and k. So let's add u plus v. So it'll be 3, which is 2 plus this one here, and then 1 plus k. So this is a and b. U minus v, that will be 1. 1 is coming from 2 minus 1, and then 1 minus k, so that will be c and d. So let's find the dot product of this vector and this vector. So it will be 3 times the 1 plus 1 plus k times the 1 minus k is equal to 7 over 2. So this is 3, and this is the difference between two squares. 1 minus k squared is equal to 7 over 2. 3 plus 1 is 4. Let's multiply by 2 here on both sides of the equation. So that will be 8 minus 2 k squared is equal to 7. So 2k squared, take it on the other side, bring 7 on this side is equal to 1. So k squared will be half. Now k will be plus or minus square root of 2 divided by 2. Example number 4 is a good question. We have a vector h. The components are minus square root of 15 and k. Find the dot product of the vector h and itself if its magnitude is k plus 1. So in the solution, we see vector h is given here, minus square root of 15k, and the magnitude of h is given k plus 1. Let's use the dot product of the same vector. U dot u is equal to magnitude of u squared. We can apply that to vector h. So h dot h will be the magnitude of h squared. So we can see minus square root of 15 times minus square root of 15. So this is like AC plus BD, k times k here, is equal to the magnitude, which is k plus 1 given squared. So now we have to expand the equation here, simplify all this. On the next slide, we can see the continuation. So we have 15 here plus k squared is equal k squared plus 2k plus 1. You remember, just expand here. K squared is cancelled. 2k is equal to, take 1 on the other side, 14. K will be 7. Now h dot h, we can find it in two ways. We can find it as the definition, which is minus square root of 15 minus square root of 15 plus k times k, 7 times 7. So that's 15 plus 49. Or h times h will be the magnitude squared. We remember, k is 7. 7 plus 1 squared. 8 squared is 64 also. That's the dot product. Another example 5, given the vectors u, v, and w, find the value of u dot v times u dot w. So let's find each one first and then multiply the numbers. Now the vector u is 2, 1. Vector v, oh, look at vector v. Vector v is minus 3j plus I. Be careful to rearrange it. So vector v is 1 minus 3 there, and vector w is 3, 4. So u dot v, so 2 times 1 there, plus 1 times minus 3, that's all the dot product, u dot v. Now u dot w, 2 times 3, plus 1 times 4. Just put the numbers there, 2 minus 3, 6 plus 4. So that will be minus 10. Now the dot product theorem is very important because we can find dot product using the angle between the vectors. Now let's call it alpha, please. Alpha is the smallest non-negative angle between the two non-zero vectors u and v. So alpha between 0 and 180. So we can write the definition here. The theorem will be u dot v will be the magnitude of u times the magnitude of the v times cosine of alpha. Remember, alpha is the angle between the vectors, and it should be between 0 and 180. Now we can solve this equation. See, this is the equation here for cosine alpha. So I can write cosine alpha will be u dot v, that's a number, divided by the magnitude of u times the magnitude of v. So alpha will be cosine inverse of that number. So this is a number inside. Find the angle whose cosine is this number here. That will be alpha. We can find it now in many examples. We will see. Let's see, example number 6. There are 3 parts, and we have to find the smallest positive angle between the vectors. Mn in part A, xy in part B, uv in part C. So there are 3 questions here in example 6. Now let's see the first one. M and N, 0, 3 and 2, 2. Let's find the angle. So we know cosine of alpha will be u dot v divided by magnitude of u times magnitude of the v. So cosine of alpha will be 0 times 2, so easy, dot product, plus 3 times 2. Divide by the square root of, this is the magnitude of the u, 0 squared plus 3 squared, times the magnitude of the v, 2 squared plus 2 squared. Now in the numerator we have 6. Here we have 9, square root of 9. Here we have 4 and 4, square root of 8. Just simplify the numbers carefully, please. And let's see on the next slide what will happen. So cosine of alpha will be 6 divided by 3, see the square root of 9. This is 2 times square root of 2. So it will be 1 over square root of 2. When you rationalize it, you get square root of 2 over 2. So what is this angle? Alpha cosine inverse square root of 2 over 2. Remember, alpha between 0 and 180. And since this is positive number, it should be in quadrant 1. And the angle is 45 degrees, or pi over 4 radians. Let's see part B. The vectors x and y. Same formula, just different numbers. 2 minus 6, 6 and 2. So let's find the dot product. 2 times the 6 here. See, this is 2 times the 6 plus minus 6 times this 2 there. Divided by the magnitude of this one. 2 squared plus minus 6 squared times the magnitude of the y. 6 squared plus 2 squared. And we can simplify it, please, and check it before you see the next slide if you like. Let's go. So it will be 12 minus 12, which is 0, over square root of 40 square root of 40, when you simplify that. So this is 36 plus 4. So 0 over 40 is 0. 0 over any real number not equal to 0 is 0. So alpha will be cosine inverse of 0. What is the angle whose cosine is 0? And this angle between 0 and 180, it will be 90. Now, when we see the angle is 90, we can call the vectors perpendicular or orthogonal. These two words, they have the same meaning. Please try to remember. So two non-zero vectors are perpendicular or orthogonal if the dot product is equal to 0 or the angle between them is 90. So when we have 90, if the dot product is equal to 0. Let's see a C part where we have U and V. Now U is -1, -2. V is -1, 3. So as we have seen, cosine alpha U dot V divided by magnitude of U times magnitude of V. Just put the numbers there, -1, -1, and then plus -2 times the 3, which is 1 minus 6. And this one, the magnitude of the U will be square root of 5. Easily you can find that. Magnitude of V will be square root of 10. This is 9 plus 1. So let's continue on the next slide and see -5 divided by square root of 5. And this square root of 10, I can split it into square root of 5 times square root of 2. So this will be 5 here. So I can cancel the 5. -1 over square root of 2. When I rationalize it, it will be a negative number. But this is a known angle, special angle. Minus square root of 2 over 2 is the cosine of the alpha. So alpha will be cosine inverse minus square root of 2 over 2. Since this is minus, alpha should be in quadrant 2, which is between 0 and 180. So this angle will be 135 degrees or 3 pi over 4. Now, I will show you a very nice summary of the dot product and the angle between the vectors. See, dot product is a real number. Dot product is a real number. It can be positive, it can be 0, it can be negative. So if the dot product is positive, as we have seen in example 6a, the angle between them is acute. We have seen the 45 degrees as an example. If the dot product is 0, then the angle between them is right, which is 90, we have seen in example 6b. And if the dot product is negative, then the angle is obtuse, which is between 90 and 180, and this is in example 6c. This is so nice to try 3 different examples that will give you the summary in this table. This is an interesting question. If the vectors u and v are orthogonal, find all the values of k. See, we have the vector u, sine 3 pi over 4 j plus cosine 3 pi over 4 I. Now there is a little trick here in the arrangement. And v is 4k plus 1k minus 3. I'm telling you in the question that the vectors are orthogonal. Let's find all the values of k. Let's see. So let's rearrange the vector first here. So this is cosine 3 pi over 4 I. See, we put the I first, and then the j with sine 3 pi over 4. So this is the vector u. Vector v is given there. Since he said in the question that the vectors are orthogonal, that means the dot product is equal to 0. So I can take cosine 3 pi over 4 times the first component 4k plus 1 plus sine 3 pi over 4 times the second component k minus 3 is equal to 0. Now I know this 3 pi over 4 is in quadrant 2 and the cosine is minus square root of 2 over 2 from the table, trigonometric table. Sine 3 pi over 4 will be positive in quadrant 2, square root of 2 over 2. Now you can multiply here easily. This is a linear equation. But to make it simple, try to multiply both sides by 2 over square root of 2. So this will be canceled. And this will be canceled here. If you try this trick, multiply by 2 over square root of 2, because we have both square root of 2 over 2. So the reciprocal will be 2 over square root of 2. So we have left with this minus 4k minus 1 plus k minus 3 is equal to 0. Solve for k, k will be minus 4 over 3. Now I will leave as usual some questions from old exam question to practice. We have a vector u, v, and w. Find this value here. And then this is a very nice question. I think we have a vector u and v, and theta now is the angle between the vectors. Find the value of secant 2 theta. This is a vector t and y are orthogonal. Find the product of all the values of the k. Number 4, we have a vector u and v. U is a2, v1 minus a. Find the value of a if the vector u plus v, so you have to add the vectors, u plus v, is orthogonal to the vector 3j minus 2i. Be careful there, please, and try to understand the question before you do it. Number 5, we have given the vectors u 0 minus 5 and vector v 2 and 2. Find the smallest positive angle between the vectors u plus I and v plus j. Also be careful, there is a little trick here. Number 6, if x is a vector of magnitude 2 and direction angle 160, and y is a vector of magnitude 3 and direction angle of 40, find the value of the dot product x dot y. Number 7, given the vectors u and v, show that u minus v dot u plus v is equal magnitude of u squared minus magnitude of v squared. Then in the b part, find the value on the left side, u minus v dot u plus v, which is equal the quantity on the right side. Find the value or the values of x if a vector u here is a unit vector. That's the only given. We have a vector u. The components are x minus 1 over 4 and the y square root of 3 over 4. It is given that this vector is unit vector. So try to remember the meaning where the magnitude is 1. I'm just telling you. And then try to find the x values. Now here are the answers of the 8 questions. For complete solution, please, you can see the video on dot product, lecture number 28, pre-calculus old exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is pre-calculus course, lecture number 28. I wish I can see you in another video with another topic. Thank you for listening. Bye.